Section 11.3 and 11.4, ellipses and hyperbolas. This section looks at what happens if we take kind of the basis of the circle equation and change some of the stuff. And where that's most evident is with ellipses. So an ellipse is a collection of all points in the plane, the sum of whose distance from two fixed points called the foci is constant. So what that means is, imagine taking two fixed points here, which are the foci, and then having a string that would go around this pencil and back to this foci. So run a string from here around the pencil into the foci, and then take this pencil and just gradually move it, keeping the string taut. And if we keep the string taut, what we're going to get is an ellipse, which is an oblong, I guess you could call it an oblong circle. So with this ellipse, this distance here plus this distance is always going to be the same. The foci are called F1 and F2. The major axis is the line that contains the foci, so whatever line contains the foci, that's the major axis. The center of the ellipse is halfway between the two foci. The minor axis is the line through the center perpendicular to the major axis, and then the vertices are 2 points I should fix that just the vertices are 2 points of intersection of the ellipse on the major axis. So wherever wherever it intersects on the major axis, those are the vertices. And then the length of the major axis is the distance from one vertex to the other. Some symmetries: an ellipse is symmetric with respect to its major axis, so we could fold it over this line here, the major axis. It's also has symmetry with respect to its minor axis, so we can fold it over there. And then we actually get to an equation of ellipse. Now, the equation of ellipse, specifically look right here, this part right here. This should look very close to a circle, except here, this is always 1, it's a constant. And then here, we're dividing the x and the y by something. By dividing the x and the y by something, that's what is going to kind of elongate the circle. So an equation of ellipse with center at 0, 0 and foci negative c0 and c0, those two foci are going to be symmetrical to each other. And vertices at negative a, so if we have a vertice here and fold it over, we have another vertice here, is x squared over a squared plus y squared over b squared, where a is greater than b, which is greater than 0. What this is saying is that what's underneath the x, if it's elongated this way along the x-axis, that's going to be the larger bottom. So whatever has the larger bottom, that's the way that it's elongated. And b squared is equal to a squared. So if we know what our two vertices are, and we know what our foci are here, then we can go ahead and find where that point there is what this last part is saying. Now take a look at this one. The previous one, the major axis was along the x-axis, and the major axis was along the x-axis when the part in front of or underneath the x squared is the largest. If the part underneath the y squared is the largest, then the major axis is along the y-axis. So here, a squared is greater than b is greater than 0. The only thing they're switching are the a's and the b's, and they're doing that to show you that when this part here is larger, then we have a major axis along the y-axis. So again, comparing these two, when you look at these, everything should look identical except where the a squared and the b squared are. So they flip those and they flip those. This is what's saying if what's underneath here is the largest, then the major axis is along the x-axis. If what's under the y-squared is the largest, then the major axis is along the y-axis. So, analyze the equation, that is, find the center, vertices, and foci of the ellipse and graph it. Center, this center is going to be at 0, 0. The reason it's at 0, 0 because both the x and the y's, nothing is being added or subtracted from them. So this is just a standard ellipse. Find the center of the vertices. Vertices are along the, in this case it's going to be along the x-axis. So here the largest is underneath the x. So I know the vertices, or I know it's going to be elongated along the x-axis because this is largest. I don't know exactly what it's going to look like yet, but I know it's going to be elongated along there. The vertices are going to be, well, the vertices, if I look here, let's see, vertices are at negative a, which is the square root of that. So negative a, the square root of 9 would be 3, negative 3, 0. And also that's one of the vertices. The other vertice is going to be at 3, 0. And that should make sense because if you put negative 3 in here, negative 3 squared is 9 over 9, which is 1, plus 0 squared over 4 is 0, we will get 1. So there's our vertices at negative 3, 0 and 3, 0. Foci. So our foci here, our foci are at negative c and positive c. We can find c by this equation, this part right here, the b squared, which is the 4, or the smaller part. So we'll take a 4 minus, or is equal to, the a squared, which is what's under here, 9 minus the c squared. What this is saying is that 9 minus 4 is equal to c squared, or c squared is going to have to be 5. That's our c squared. Our actual foci is just c, so we have plus or minus the square root of 5. Our foci are along this axis. These are going to be x coordinates, so we have negative square root of 5, 0, and square root of 5, 0. There. So we found, let's see, we found the center, vertices, and foci. So when we graph it, center, when I go ahead and I graph this, I have a point negative 3, 0, 2, 3, 0, 1, 2, 3, 0. I've got those 2 points. An additional point I can find comes from right here. If x is 0, my intercepts, my y-intercepts, if x is 0, this part's 0, so the y is going to have to be plus or minus 2. So I've got those 2 additional points right there. And then when I connect the dots, I'm going to end up with something kind of like that. The foci are roughly, right about there and there. So again, if I were to connect a string and took my pencil and gradually moved it around, keeping that string taut, this is the graph that would result. Another try at this, find an equation for an ellipse. So this time we have to find an equation based off of this information. Graph the equation. I'm actually just going to graph what I have now already. The center's at 0, 0. The foci is at negative 1, 0. So there's a foci there. If there's a foci here, there has to be a foci here. So negative 1 and positive 1. A vertex is at 3, 0, so we have a vertex here, a vertex here, and then we're going to have something like this. and the foci 1, 0. So 2 foci, 2 vertexes, like that. The equation, I know there's going to be, this is elongated along the x-axis, plus y squared. These are going to be over something equal 1. Well, the a squared here comes from the vertice. So if I square this vertice, this vertex, this is going to be 9. How am I going to get this right here though? The b squared. Well, the b squared comes from the a squared, which is what's underneath here. So the 9 minus the c squared. C comes from the foci, which is -1, so minus 1, -1 squared is 1. B squared is going to equal 8. And b squared is what's supposed to go under there, so I can just leave it like that. And there I have the equation for the ellipse. Another type of kind of variation, I guess you could call it, are something called hyperbolas. And what a hyperbola is, it's the collection of all points in the plane whose difference, this one should say, it should say difference of distances. So whose, right in here we should say difference of distances. Ellipse, it was the distance whose sum is equal. Well, this one is the difference of distances from two fixed points called the foci is constant. So before, the sum of the distances was equivalent. This time the difference is the difference of distances is constant. So here, this is what a hyperbola would actually look like. We have our two foci. If we take a point on the axis, so take a point on the axis and go from this foci to that point to this foci, the difference between those two lengths is always going to be constant. So if I take another point here and go to that foci and this foci, the difference between these two is going to be the same. Equivalently, if I went to this point here, the difference between these two lines, the two distances, is going to be constant. That's what a hyperbola is. And I'll get rid of some of that so we can still see the original information. Alright, so a transverse axis is a line containing the foci. This right here is the transverse axis. The center of the hyperbola is the midpoint between the two foci. The conjugate axis is the line through the center, perpendicular to the line through the transverse, or the line through the foci, which is the transverse axis. And branches are the two separate curves. Here we have one branch and the other branch. They are symmetric with respect to the transverse axis, conjugate axis, and center. So we can spin this 180 degrees, we can fold it over this line or fold it over that line. The vertices are 2 points of intersection where it's crossing the transverse axis, and we have foci F1 and F2. What do you suppose the equation is going to look like if it's the difference of different distances? Well, if it's the difference of distances, it almost looks like a equation for an ellipse, except for now we have a minus in here. So before it was a plus, and now we have a minus. When it's a minus, then the equation is going to be that of a hyperbola. And we have this part here, how we can find these bottoms based off of the foci. This one right here, if the x squared part starts off, then the transverse axis is along the x-axis. However, if the y squared starts off, then the transverse axis is along the y-axis. So if you see y squared start, transverse is along the y-axis. If you see x squared start, the transverse is along the x-axis. So find an equation for the hyperbola, graph the equation. The center 0, 0, focus 0, 5, and vertex 0, 3. Now this one doesn't list it, but keep in mind the equation is x squared over a squared minus y squared over b squared equals 1. And if we go back, the b squared is equal to c squared minus a squared. Now this one right here, this is when, which one is the transverse axis? This would be the x is the transverse axis. Let's see if this is the one we need to use. Here we have some of the information about this hyperbola. So the center is at 0, 0. Focus is 0, 5. Vertex is at 0, 3. So we're going to have those same points except reflected. This is the vertex here. So it's going to look something like this. Well, let's see here. This one right here, the transverse axis, is along the y-axis, which means y squared is going to have to start off. Instead, we're going to use y squared over a squared minus x squared over b squared is equal to 1, like that. So the y squared is going to be over something minus the x squared over something is equal to 1. Y squared over a squared is a comes from this point right here, the vertex. The vertex is at 3, so we're going to use 3 squared or 9. 3 squared or 9. And let's just double check that. If we put this point into here, if we put 3 in for the y, 3 squared over 9 is going to be 1 minus 0 squared over something. Yes, that's gonna work out. So that part's gonna work out. Now to get our b squared comes from the c squared, which is the foci squared. So 5 squared minus the a squared, which is the 9. So our b squared is going to equal 25 minus 9, or our b squared is equal to 16. Like that. And there we have our equation for the hyperbola. Should we try it one more time? So find the equation of the hyperbola. Here, if I put this information down here, our center is at 0, 0. Our focus is at 0, negative 6. Oh. Our focus, why don't I just erase that so there's not confusion. So our focus, 0, negative 6. Our vertex, 0, 4. There's going to be symmetrical. So here we have our what it's going to look like on a graph. The transverse axis is along the y-axis, so I know that y squared is going to have to start off. A squared minus x squared over b squared is equal to 1, where b squared equals c squared minus a squared, like that. So y squared over a squared. A squared comes from the vertex, or 4 squared, or 16, minus x squared over b squared is equal to 1. Our b squared comes from the c squared, which is our focus, negative 6 squared, 36, minus the a squared, which is 16. Our b squared is going to equal 20. and the b squared is what we want right there. So we're going to get y squared over 16 minus x squared over 20 is equal to 1. Like that. I think that's the pertinent information that you need for hyperbolas and ellipses. Good luck, and hope it goes well.